Hello, I'm Robert. I'm just talking through this article on science that Dr Maria van Kerkhove has just shared. She's a technical lead for COVID with the World Health Organization. And it talks about how many governments are counting on Omicron needing less stringent lockdowns. And they're banking on the early indications that that the vaccines still protect against severe disease, and that Omicron may be gentler. And they say it's a risky bet because the science isn't in yet to say what's going to happen for sure. So, and then if we go and have a look down here, it talks about the data from South Africa. Well, some countries will be like South Africa, and Omicron put us third as many people in hospital as the Delta variant did, and that's with cases already starting to fall. So if a country gets it like South Africa did, then they will weather it even more easily than previous waves. Still lots of hospitalizations and some deaths, but it's not going to be as severe as some of the previous waves. And then if you look at England and Denmark, then are there early cases, and so they're also having much less of the very severe cases. But those come with caveats. So the Omicron in the United Kingdom is spread most quickly in younger adults. That's where it's really been surging. And just recently, in England, for instance, the number in the 80s ending up in hospital with, and that's not in this paper, but I've just been reading it elsewhere on Twitter, has increased tenfold. And that's not surprising as a result of the parties and the mixing over Christmas and New Year. So we don't know yet what Omicron is going to do for older people who've, over 80s especially, who've been vaccinated and are ending up in hospital, because that is just starting. And we don't have previous history anywhere else to know what's going to happen. So that's why one of these experts is saying, I think it could be much worse than most people are thinking about at the moment. And in the United States, more than 100,000 people there were hospitalized, up from 75,000 a week earlier. And so it's too early to know what's going to happen in countries like England and Denmark that rely on vaccination. In South Africa, then they had very little vaccination in their previous waves, and many of them died, and they have a much younger population than they don't have so many of the elderly, and so they were protected in a way. Well, not really protected. The people who got this time, then they'd already had beta before, most of them, so they weren't really protected from COVID. They were just having COVID for the second time, and many of them had died, sadly, in previous waves. So it's just too soon to know what this means for vaccinated countries like England and Denmark. It does seem that if you are a young population and vaccinated, then it greatly reduces the risk of severe disease, and we are going to find out in England in the next couple of weeks what this does to the elderly vaccinated, especially over 80. So that's what we'll find out in the next 2 weeks. Then there are signs that Omicron can trigger dehydration from fever, vomiting and diarrhea, and exacerbate other health issues such as diabetes. And these need less intensive care, but they can still overwhelm the hospitals. So we're getting many critical incidents in the United Kingdom where hospitals are running out of. Now, critical incident doesn't mean that the hospital stopped working. Critical incident means that it's been flagged, that the hospital has to get in has to find a way of solving a critical situation. So they respond to declaring it as critical. They get more resources, they get more flexibility to move their staff around to do different things. And so declaring a critical incident gives a hospital more flexibility to deal with it. So we've had several critical incidents in the United Kingdom already. Hospitals saying, we're not able to cope, we've got to get extra powers to deal with the situation in our hospital. And this is not due to ICU. In the United Kingdom, in England, the ICU use is not increasing. It's the same number in ICU so far. We don't know yet for the over 80s, but for the ones cases so far, it's the general hospital use and general and acute care where all the pressure is. And that's what they're saying in this. And Dr Maria van Kerkhove says, I'm hearing story after story after story of hospitals that are full, health workers that are infected, that can't do their job. We're getting that in England too, where many health workers are off, sick, isolating, and then they try and shorten the isolation period, but there's still, still an awful lot of them are off sick. And that cuts, so you've got less staff and more cases. So, and then how severe it is to the people who are immunologically naive, then that's another situation. So most countries have managed to have either been vaccinated or they just haven't managed to keep COVID out. But some countries, like, they mentioned that Ghana, Ivory Coast and Madagascar, the vaccination rates are low and their deaths are increasing sharply with Omicron, which suggests that in people who are not vaccinated and who have never seen COVID, and Omicron may still be a very severe disease. And this makes sense of why, for instance, China, Taiwan, countries that have relied on keeping COVID out, they're super cautious about Omicron, and that's why China shuts down on Omicron. It really doesn't want it to spread because they don't have that high vaccination rates, and they've got almost no previous infection as a percentage. So that, if you're in such a country especially, you're going to probably want to do lockdowns. And or really do very strong measures. In China, that's why they're doing lockdowns. They've got to in a very different situation from everyone else. So that also talks about what has changed in Omicron. So first of all, there's SARS-CoV-2, it has two ways of getting into a cell. So after binding to the ACE2 receptor, which is how it gets into the cell, then either the virus can fuse with the cell directly, so it goes in directly where the receptor is, and then it makes its own little container that helps it get into the cell. And the other way is it can be swallowed by an endosome, which is a kind of vesicle in the cell which is used for bringing things into the cell. So it actually tells the cell, bring me in, and this endosome comes and brings it. And then it has to get out of that into the cytoplasm in the cell. And there's when the virus leaves the cell, just after it's been made, then as it goes out, there's a little enzyme that cleaves the spike protein that then makes it more able to get into a cell again when it comes into the cell next. And early lab studies show that that Omicron isn't doing this so well. That's the enzyme this TMPRSS2 that cleaves the spike protein, that makes a little snip on the surface of the virus, which then makes it more easily able to infect the cell. And that's not happening so much with Omicron. And on the other hand, Omicron is coming in the other way, using the endosomes. So it's now a very clear preference for the endosome removed. So some people argue, and some evidence, it seems to be sparing the lungs and going more for the upper respiratory tract. And there's and some researchers argue that this enzyme, which cleaves the spike protein, so this enzyme is there already, and it cleaves the spike protein less efficiently than for other variants. And some researchers argue that this is because this enzyme is more common on cells in the lower airways. There's very little data to support that. Another thing, and this is with images of cultures which have been infected with Omicron, then if you do it with Delta, you get these very distinctive big clusters of cells all fused together into a single cell with lots and lots of nuclei, which is called a syncytia or something like that. And this may be part of what causes severe disease. And they're saying here that cells infected with Omicron may be less able to do that. So what happens is that you've got Omicron turns a cell, or Delta turns a cell into a virus-producing factory. It's very specialized and dedicated, and all it does is produce viruses. Just about all the other cell processes are stopped. And then your immune system, then you get these killer cells that spot that this cell looks different. They come and try to destroy it. But as it approaches, then the virus cell fuses with this approaching cell and turns it into a virus-producing factory. And then you can end up with lots and lots of cells all fused together, and other cells as well, and they all fuse together to make one big virus-producing factory. And cells infected with Omicron may be less able to do this, and this may make it less severe. So if you look at the viral biology, it very much suggests that we're looking at a less severe clinical picture, changing in how the viruses infect and what cells they infect. And it's possible that this has shortened the time between exposure and onset of symptoms from 5 days for previous variants, 4 days for Delta, and 3 days for Omicron. And then it may also be that it's spreading faster because it's better able to get around the immunity from previous infections. So they found that if you look at households with a Delta outbreak, then you had half the risk of getting infected if you were vaccinated. But if they're infected by Omicron, then there's no difference in your risk of getting infected. On the other hand, the vaccines clearly stop more severe disease, and also in a Danish study, a booster shot cut the risk of being infected by half. So if you've got a booster and you're in the same household, you've got half the risk, and that's back to the same as Delta was without a booster. And then also, even without a booster, an unvaccinated person is 41% less an unvaccinated person is 41% more likely to infect another person. So you have nearly 2/3 of the risk of infecting someone else if you're vaccinated. So it reduces by nearly 1/3 your risk of being vaccinated, your risk of infecting someone else. So the vaccination, even with Omicron, will be doing something to reduce transmission, and the booster, presumably they don't talk about the booster there, presumably reduces your risk of transmitting to others even more. I mean, only half the chance of symptomatic disease. What was it? Yes, only half the chance of being infected, so that would be a case of positive. You've got unvaccinated case for booster risk of infections, that would be a case of positive by half. So if you're boosted, then your chance of being infected at all is halved, and then also be a reduced risk of infecting others. So even if you are infected. So that suggests if you're boosted, that would do even more help to reduce transmission. And there's another possibility. It might be that the reason that it spreads so fast, it might be also, so that's two reasons so far. It could be it spreads so fast because of the shorter time for incubation period. It could be because it's escaping immunity, so vaccinated people get infected and spread on to others more than with Delta. And it could also be because if it's really is better at replicating the upper airways, it might be that it's more likely to trigger super spreading events because it's more easily spread into the outer air, in surrounding air. So if you're, like say, in a party with lots of people, more easily to spread others. If that is true, and it's just too early to know, then concentrating on super spreading events may be a way to restrict it. And so banning large gatherings and closing down nightlife and restaurant, which has been very effective with Delta, maybe even more effective with Omicron. And that might be a top priority thing that you can do, rather than a full lockdown, is to stop banning these large gatherings and banning restaurants and nightlife. And this is just for a short period, because these spikes in hospitalisation, in cases and hospitalisation, are going to be very short. The projections for the United Kingdom are of our models are of a spike that will probably peak in the maybe the second week of January or something. And these are cases of people that have already been infected, and hospitalisation would peak in the second week of January. That is if the case is already just about to peak. Hopefully the case is already about to peak in England. And if that's right, it's already has peaked in younger people in London. And it may be about to peak in the other age groups, maybe in the next few days. If that's right, then hospitalisations may peak 2 weeks from now. And then the models show a very sharp fall in cases after that. So that by the beginning of February, we're back to lower cases than we are now. So that's what we can expect generally with Omicron, a very high peak and then coming down. But we only have views of the other side of the peak so far from South Africa, where it's encouraging to see this coming down very fast in the peak in South Africa, just as fast as it went up. Now, is it, on the question about whether it's milder than earlier cases, then there's another thing they say. Now, where is it they say that? It may take a little while to find it. Yes, but one of the reasons, when they say it's less severe, then Omicron, Omicron is rather a surprising thing about the gene sequences of Omicron in GIS8 is that Omicron is most closely related to sequences from 2020, spring, summer 2020. And it doesn't seem to have interacted with the rest of the sequences in GIS8 since then. One hypothesis is that Omicron may be a variant from 2020 that went into rodents. As some researchers, I think that because it's got some genetic changes that have been spotted in studies in the lab of infecting rodents with COVID. And these same genetic changes, that's again, it's not in this article, I'm just adding some extra information. And those same changes are seen in Omicron, as are seen in lab studies where rodents are infected and now to infect other rodents. And so one strong hypothesis is that it spent a year in rodents and evolving in those rodents and then jumped back to humans. And this could have happened anywhere in the world. This rodent population has not been discovered if this did happen. And the cases in South Africa, they came from Botswana. Cases in Botswana came from 5 delegates who came from other countries. And because of the stigma that was given already to South Africa and Botswana, Botswana is not revealing where those delegates originally came from. But they have said that they reached Botswana, some of them reached Botswana through Europe. So they've been to Europe first, then to Botswana. So it's entirely possible that Omicron started in Europe, originated from Europe. It's not impossible. I mean, for instance, case in some of the European countries had Omicron very early on too. And maybe when we trace it all back, we'll find that it's been circulated in Europe as well. Botswana was very fast at testing, and so was South Africa. Very fast turnaround, and they found very early cases, and they were testing very well. And there could be other countries in other parts of the world that didn't have such a good net and that was because of an initiative from the World Health Organization in Africa to greatly increase Africa's capability for testing. and because Botswana and South Africa had cases very low because they'd managed to reduce Delta so much. And the combination of those two meant that they were one of the best places in the world to spot Omicron early on. It would have been spotted very early in England too, so it's not like it started here. But there are plenty of countries in the world where it could have been and just wasn't seen. So Omicron could have started in rodents almost anywhere in the world. And it could have been in those rodents for a year and then jumped to humans. Anyway, so they're saying that although COVID is less severe, it may be milder than Alpha or Delta, I'll just highlight that bit, but it branched off from the family tree before those variants emerged. Is it milder than ancestral COVID or than D614G, the first variant that we had? And Katsorakis says that we don't know the answer to that. Don't think we know the answer to that because COVID got more severe with Alpha and got more severe again with Delta. So we got used to dealing with a variant of COVID that sends more people to hospital with more severe disease and than the ancestral COVID. And now we suddenly get Omicron, and Omicron may just be similar in severity to ancestral COVID. They don't know if it's any different. And so this does not necessarily mean that Omicron is going to evolve to be milder. It hasn't necessarily evolved to be milder. It may well have not evolved at all in a direction of mildness. And if it's spent the last year in rodents, say, then spreading in rodents is not going to make it more fit to is another thing that wouldn't necessarily contribute to severity. And this is something that Dr. Mike Ryan has said in, he said previously, I talked about, I've got another article about that, and he said that, and I've got another article that I can link to in the video description, but I've talked about that separately, and this is about which way will COVID evolve, and it's got new variants will evolve to be more transmissible, because that strong pressure on the virus to do that, immune escape and being more transmissible. But the virus has left your body before you end up in hospital, or not long after you end up in hospital. And it's in the very early days that you're most infectious. And apart from in people who are strongly immunocompromised, and by the time you're needing oxygen, by the time you're needing severe disease, you're in ICU, then the problem is your immune system. If you've got a healthy immune system, then your immune system is the problem after that. And the damage that the virus has caused to your body, and then your immune system attacking that damage. And that is why, at that point, dexamethasone, which dampens down your immune system, you shouldn't use that in the early stages because you need your immune system to fight the virus. But if by the point at which you need oxygen, then that reduces your risk of dying because it is dampening down your immune system, which is what's causing the problem at that stage. So the pressure on the virus is to become more transmissible, which means to have more, and that can involve a higher viral load in the early stages. And a higher viral load in the early stages can lead either way, but it can lead, and there's some correlation of higher viral load in the early stages with more severe disease. So it is possible that evolving to be more transmissible, it can go either way. And the World Health Organization say we simply can't know if a more transmissible variant will be more or less severe. And it could, because the severity happens long after the virus is gone, and the virus is severity agnostic. It is not going to evolve in a way that is, the way it evolves is related to transmission, to trying to produce lots of virus early on that can be coughed out or sneezed out to infect someone else. It just doesn't care about what happens to your lungs and what happens to your other organs of your body, and it doesn't care about how your immune system responds to it in the later stages. So it's severity agnostic. And so the next variant, we don't know if it's going to be more severe. There are several, but what may help is that Omicron may help to tame what is coming next, because just as Delta helped to tame Omicron, then because we're rapidly surging up vaccination in response to Omicron, huge increase in boosters in the United Kingdom, and huge increase in first doses and second doses in other countries that haven't, and in first doses and second doses, a huge increase here in England. So I'm talking about England as an example of vaccinated countries. One very good thing is that we've now got Novavax, which is going to greatly increase the capability of countries like Africa to do the first and second dose vaccinations that they so desperately needed. And that adds to natural immunity from being infected previously by COVID, and now with the Omicron. Then, although Omicron is not likely to be the last variant, it's highly unlikely that it is the very last variant we will have. But as Haneke says, I suspect that immunity post-Omicron will be pretty broad, because most people will, and many people will indeed, will be infected by Delta and then reinfected with Omicron. So they will have immunity against both Delta and Omicron. That's why he's saying that their immunity will be pretty broad. For instance, those people in South Africa, they were infected by Beta and then by Omicron, and some were infected by Delta and then Omicron. So there are lots of people around now that are either vaccinated and they're fully vaccinated and then they're infected. Because remember, it is spreading an awful lot through fully vaccinated people. And so there are lots of people around the world after the Omicron surges. There will be lots of people who have been vaccinated against ancestral, which is also very effective against Delta, and then they have been infected with Omicron. There will be people who have been vaccinated against Delta with a booster, that's like me, and who've never had COVID, but the booster makes them more protected against future variants, because it's much broader protection. For some reason, when you have a third dose, 3 months or 6 months later, that gives you broader protection against all variants, not just the ancestral. The ancestral variant that Pfizer is the vaccine for, then that is actually quite a good variant to use if you're going to choose just one version of COVID to vaccinate someone with. Ancestral may be the best one to use, because suppose that we had done what some people were suggesting and vaccinated lots of people against Delta and did a big priority of vaccinating against Delta. That might have been less effective at protecting against Omicron than the vaccination we already have against the ancestral. So because everything, including Omicron, because the ancestral is so long ago, they are all derived from that. So they're far more common, they're likely to have something in whatever is common to ancestral, that vaccine. And so the 3 doses of Pfizer or Moderna or AstraZeneca or a mixture of some of them, then 3 doses, now Israel's now looking at 4 doses as we get more and more vaccine capacity. And lots of doses of those will give you broader and broader protection against all the variants that are derived from the ancestral COVID. And so there's something to be said for continuing to vaccinate against ancestral. And so they are investigating in doing variants. The other possibility is to have a vaccine which is multivariant, which will vaccinate, say, against alpha, beta, gamma, delta, Omicron, and ancestral. And then also, and this is a rather interesting new vaccine being developed by the United States Army, where you can put many, I think 20 odd vaccines, all on the same spikes, all in the same core unit. And their vaccine vaccinates against multiple variants of SARS and multiple variants of COVID. And the various other ways that we can have multiple variants. And we've got lots of these second and third generation vaccines coming along. We've got the Cordogenics, which is an attenuated live vaccine, which is very, very safe because it uses a method that is designed using science, which makes the virus only able to change very, 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 very slowly. And so it's a very safe attenuated variant that has passed phase 1, and that is mucosal. You get as nasal spray. And we've got these three types of vaccine of immunity. We've got the antibody immunity, then we've got special kind of antibodies, the IgG in the nasal, in the mucosal, whatever you call it, and then we've got the T cells which go around, and they're especially helpful for stopping the severe disease. They go around killing the virus factories in your body. And the mucosal immunity, where IgG antibodies, is may be especially useful for preventing you from infecting other people, as well as stopping it very quickly before it gets into your body. And Cordogenics, because it's a nasal spray and it's sprayed into your nose, and others that are looking at nasal sprays may be able to stop transmission very well, because it's a mucosal immunity. And so then there's the mucosal immunity, that's multi-spike idea, and then if you've got very good T cell immunity, then that can help as well. But it's likely we're going to be using maybe a mix of several vaccines. So targeting all three is what works best of all. So you've got a vaccine that targets the T cells, that targets the antibodies, that like our current vaccines do, and also targets the IgG mucosal antibodies. And so we've got these new vaccines coming along, and they are being funded by the World Health Organization, by the CEPI, and by the private donors, and by the weaker economies. So countries like Brazil and India and Thailand, Turkey, they are all sponsoring the next round of vaccines. And the reason they're doing that is because they are not being given access to the best vaccines so far, the Pfizer, Moderna, so only AstraZeneca that is actually really done a very strong job of trying to get their vaccine to all the weaker economies and transferring the technology so they know how to make it, so that Indian factories can make it. So Indian factories, which are one of the world's biggest suppliers of vaccines, they're making AstraZeneca. They haven't been told how to make Pfizer or Moderna. And Pfizer and Moderna could have transferred their technology to India in autumn 2020, but they didn't. And so that's why we have so much more AstraZeneca in the world than we have of Pfizer and Moderna. And so because of that, then the weaker economies, they want more vaccines and they want the best vaccines, and they are developing their own version of like Pfizer and Moderna. So does the Africa is developing with the RNA vaccine hub. It's developing new RNA vaccines. And the science has evolved a huge amount in just the 2 years, 2 years since early 2020 through to late 2021. And as a result, the next generation mRNA vaccines and all the other vaccines, they are much better, because there's been a huge amount of research into vaccines. And these new vaccines that are coming along are going to be better than Pfizer. The spike is more stabilized and more stronger. It's got the hexapro tweak, which means it's a very stable spike that looks exactly, so the spike of the virus keeps changing. It's very morphic, very changeable, metamorphic, or whatever the word is. word isn't coming to my mind what that means. It's a shapeshifter, and it's constantly changing shape, and there's only one particular shape that gets into the virus, the cell, and this is where it hides from your immune system. And the Pfizer vaccine stabilizes this shapeshifter, which is why, probably why it's better than it's so much better than the inactivated whole vaccines. And but the next generation stabilizes this spike even more, much more strongly. So nearly all the spikes look exactly like they should do when they go into a cell, so the antibodies can recognize it much more easily. And these vaccines are being developed using methods such as that. And those are the ones that are coming along in this first quarter 2022 and the second quarter. And so we've got these mucosal vaccines. We've got the vaccines that are multiple spikes on the same vaccine, and we've got vaccines that have got much more stable spikes. And we also have the ones that target the T cells, and they are that's like Gritstone Bio. And Gritstone Bio, it's lost almost none of its effectiveness with Omicron. It only lost 3 out of 146 T cell epitopes. So this tells your T cells what to look out for when they go around hunting your body to virus factories to destroy them. And the Gritstone Bio, then it has been developed using things that they knew in advance would hardly change from one variant to another. They looked at things that are common to all the variants, and then they said, well, look, this hardly changes. It's the innards of the virus. It's the way it makes itself inside the cell. So instead of the outside and what it looks like to the antibodies, it's the innards as it's constructing itself inside the cell from the bits and pieces that come together in a marvellous way inside the cell. You see, especially its own designed. There isn't an RNA replicating machine in your cell. So an RNA virus has to make its own replicating machine. And it's hugely haphazard. It's very strange compared with the machines that we're used to. It's huge, higgledy-piggledy, haphazard thing. It just sort of spurs out lots and lots of chemicals into your cell, and they sort of self-assemble, and they rather spontaneously, magically produce viruses. And so when the cell is doing that, there's lots of innards of the virus sort of swimming around inside the cells inside the cell of these various factories, just in a haphazard way. And then the T cells can spot these innards of viruses, and these innards vary much less than the outsides of the viruses do. And so Gritstone Bio has looked at some of these innards and some particular ones that vary hardly at all. And they may be that they don't vary because they can't vary, because if you vary them, then this device can no longer make copies of itself. So that's another one. That's Gritstone Bio. If that works, and that's in phase 1 at the moment. I think it's just completed phase 1. So there are all these vaccines. They could go to phase 2 and then phase 3, and they can go through very quickly, just like happened with the previous virus vaccines. If just depending on the funding, and the funding is coming. So there's funding coming to help these, and it's for the weaker economies. So the weaker economies is what is funding the next round of vaccine development. And so unlike the first round, where the vaccines were mainly distributed through bilateral deals with wealthy economies, and the weak economies got left out, in 2022, the vaccines will be done through deals through COVAX, almost entirely. And there'll be some other ones, but they all will be done because they're developed by weaker economies. They have the needs of other weaker economies in mind, and so they're likely to have these deals with, like for instance, with the Serum Institute in India and other places around the world, so that weaker economies can make their vaccines so that they're affordable to other weaker economies like themselves. The stronger economies tend to make vaccines that are affordable to stronger economies. The weaker economies, and they obviously are not going to make vaccines that are so expensive that other weaker economies can't buy them. So either they make them themselves, and that's some of the weaker economies are doing, and or they're going through CEPI and COVAX, and either way, then the vaccines that we're going to get in 2022 are going to be very widely available to all the weaker economies. And this means that we'll be able to vaccinate the entire world with the very best vaccines, much faster, and we'll be able to make much more of them. And and people have much more experience of vaccinating with the vaccine distribution programs we've had so far, and they're getting faster and faster at vaccinating. United Kingdom much faster than previously with the boosters. And if you look, we're nowhere near the maximum. If you look at the speed of vaccination that's possible, then Brazil in one day vaccinated nearly all the school children in Brazil, and this was against polio, I think. Have I got it right? I'd have to look that up. Correct me if I got it wrong. I'll say in the video description. But I think it was 1970s, and they vaccinated all the school children in entire Brazil, in the rainforest, everywhere, on a single day. So and Bhutan managed to vaccinate all its adult population in just over a week. And so what we in the United Kingdom think is very fast vaccination is nowhere near the limit. And it is possible, and even for a weaker economy with huge problems of distribution in rainforests and in mountains like in Bhutan, and they can vaccinate very quickly, and they can vaccinate everyone. So we have had distribution problems in the weaker economies, but then we've had distribution problems in the stronger economies. This does not mean that the weaker economies from now on will have distribution problems. These are problems that can be solved. They hit the news because the weaker economies got their vaccines much later than the stronger economies. So the stronger economies' problems happened towards the end of 2020. The weaker economies' problems are happening towards the end of 2021. And they're hitting the news, but they're no different, really, from the weaker economy problems in scaling out the vaccines. Because if you look at, say, December 2020, many of the weaker economies were having lots of problems. Look at the United States. It was having lots of problems scaling out its vaccines and getting them to everyone at the end of 2020. And they only got solved in the spring of 2021. Well, many of the countries in Africa are in a similar situation to the way the United States was in winter 2020. And so they have these initial scaling problems. But COVAX is able to get the vaccines, so long as it gets vaccines at early batches, and it doesn't have late batches that only got 4 to 6 weeks before they're used up. They have to be used. Then it's very flexible. COVAX will ask a country, can you deliver these vaccines? And the country will say, yes, we can, we've got loads and loads of health workers, we're all ready to go. COVAX sends the batches out to this country, and then this country, it starts going out, and then it says, oh, oops, there's this problem, and there's this problem, and this problem, because it's the first ever time that they've actually even done a vaccine rollout for a COVID vaccine. And especially with, say, if it was something like Pfizer or even AstraZeneca, the various things that they have to get right, and maybe they just can't get it done in just 4 to 6 weeks. So then, as long as it's not just about to expire, in a country like, say, Nigeria, which is one of the ones that had problems because of these expiring doses, then they would just say back to COVAX, sorry, we were a little bit optimistic. You do please send our vaccines to someone else for a month or two, and we'll sort out our problems, and then send us the vaccines. So in that way, COVAX is able, indeed COVAX is much better than, say, the United States, the United Kingdom, or Europe in that respect. We don't have such a system. We don't have a system by which, for instance, if UK can't use up its doses, it would send it to another country in the EU. And as far as I know, I don't think we do. So we're not in the EU anymore, another country in Europe, sorry. But COVAX does that for the entire world. So So COVAX sends its batches. It sends us batches at a time. Then it checks whether they're being used, and if they can be delivered, it'll send more to that country. If not, they'll send it to other countries while the first one is getting up to date. So by the end of 2022, we will have lots of vaccines, and most of them will be going through COVAX, the very best vaccines. And Pfizer will not be the best vaccine at the end of 2022, highly unlikely. And I don't know what's going to happen with the big drug country, but with Pfizer particularly. I don't know what they're going to do, because they don't seem to be developing these second and third generation vaccines. But maybe they are. Do correct me if I'm wrong. We do have the US Army vaccine. Maybe they make a deal with US Army or something, I don't know. But I shouldn't say hypothetical things like that. I've absolutely no idea what's going to happen. But we are likely to get some second and third generation vaccines from stronger economies too. And they may or may not go through COVAX. I have no idea what's happening there. But we will have lots of second and third generation vaccines that are very good going through COVAX. And so we should be able to have, and these will be vaccines with mucosal immunity, with multi-spike antibodies, and very effective at T-cell fighting. And maybe we'll end up combining all of those in one shot. Maybe even 3 different vaccines, like we have with the MMR vaccine. We have multiple vaccines in one shot. Then we may well have a COVID vaccine that has, for instance, for instance, it might have Gritstone Bio, Codagenics, and the US Army multi-spike protein, or some other one using a similar technique for the antibodies. So that gives you mucosal immunity from the Codagenics, and it gives you very strong T-cell immunity from the Gritstone Bio, and then it would give you very strong antibodies, the IgA antibodies from US Army antibody spike, multi-spike antibody, multi-spike antigen, sorry, or whatever you call it. I should say here that I am no expert on any of this. I am just a science, my day job is that I'm a software developer, that I make my own software, I make software that I sell over the internet. I have been interested in science all my life. I trained as a mathematician, so maths comes with me very, very easy. Maths is very easy for me. And I do some science blogging, voluntary work. None of it is paid. Well, none of my, I hesitate a bit there, because I have my Kindle books on Mars and space, and they're available for free on the internet, but you can buy them on the but that's nothing to do with this topic. And certainly on my science fact checking that I do for COVID is completely voluntary. I get a very, very small income of a few dollars a year from another aspect of my science blogging, but nothing to do with fact checking. And so I'm a voluntary fact checker and a science blogger, and my main job is a software developer, and so I just my input here is just that I know how to read a science paper. I've watched nearly all I think probably all the press briefings of the World Health Organization since it started. I don't know if I've watched them all the way through, every single minute of every one, but I've watched most of them all the way through to the end, and all the live Q/As, and I follow this very carefully on Twitter, and I know how to read science papers. I've read the science papers, and I know how to check if they're junk science, if they're the right, if they're the proper thing. And that's the main thing I bring, and I help the scared people with my fact checking of that. So, but I've never studied epidemiology or virology. I'm no expert. I'm just an ordinary, like a responsible science blogger and that's what I bring to this. So there may very well be things I've got here that I've made a mistake. Please let me know if I said anything that's mistaken in my presentation. I've presented it as clearly as possible. And as far as I know, that's the current situation with Omicron, and the situation looks extremely positive for the future. The World Health Organization, so I know people have been saying we're going to get rid of they said in 2020 it's going to become mild like a flu in a few months. They say, oh, we're going to get rid of it. The World Health Organization have never said that. They've always said we can get rid of it. So way back in early 2020, in spring 2020, if we had brought what we know now and what the World Health Organization knew back then, but which most of the world has only discovered since then, and what the World Health Organization tried to tell the world, if we brought all that back then, to very fast build-up of testing capacity and very fast build-up of PPE and very rigorous and thorough contact tracing and so on, if we'd done all that, as China did, Taiwan did, Bhutan did, very small country, if we'd done all that in the, and especially Taiwan, Taiwan did probably even a better job than China in early 2020 in the way they fought COVID, and China did a very good job and managed to keep it out of most of their provinces. Thailand did very good early on. New Zealand and Australia did very good job early on. If you could imagine another world where you hypothetically did a parallel history, where you somehow you took China, Thailand, Taiwan, Bhutan, New Zealand, Australia, the Tonga Islands, and you made a smaller Earth, like an Earth with much more ocean and much fewer landmass. And you could somehow, in a parallel world, if you imagine like in science fiction, and it's not true in reality, but in science fiction, imagine that you had a parallel world which was like Earth, but it was covered in ocean, and it only had a big island where China is, and Taiwan, and China and Thailand and North Korea. I think North Korea kept it out, and the Tonga Islands, and a few islands in China and a few things. And if you then had everything else the same, but the rest of the world didn't exist, just those, then COVID would have been got rid of, and there would be no COVID left in the world by about March 2020. So in this sense, COVID is an eliminable disease. Even now, and even with Omicron, then we could eliminate it from the world if we used contact tracing to the rigor and thoroughness, and testing, and isolation and quarantine to the rigor and thoroughness that these countries have used. But it's not a realistic possibility that the world does that. But it is a realistic possibility. First of all, as I said, the new surges are going to be less dangerous because of maybe, we don't know, and now the reason that he says I wouldn't want to bet on it is because new variants, Omicron did a huge escape relative to Delta, and it's possible that a new variant will have a huge amount of vaccine escape relative to Omicron and Delta. If the escape is very large, then it may so evade the immunity for Omicron and Delta that our previous immunity with Omicron and Delta does very little to stop the next variant from the severe aspects of the next variant. So with Omicron, then our immune system managed to stop the severe disease but doesn't stop Omicron. And hopefully with future variants, then especially with the broad immunity we've had from Omicron and Delta, then our immune system will also stop the severe disease. But it's hard to be sure of that because we've limited experience and limited science in which to be sure of that. But with the combination, if you look further, so early in 2022, say second quarter, third quarter, then maybe we will get more, we'd likely get more surges like Omicron. It is possible that some of them may still be severe to some extent. But by the end of 2022, then we will be getting close to vaccinating the entire world with much better vaccines for anyone who wants it. And at that point, so the World Health Organization are really very optimistic that 2022 can be the year we ended. So in previous years, World Health Organization said, like in spring 2020, yes, we can stop it, but the window is closing, nobody's doing what we recommend. And they said it in February, and they said it in March, and eventually the window closed. So we lost that opportunity. Then in autumn 2020, there was when the vaccines came along, they said if we could manage equitable vaccine distribution around the world, and at that stage, with ancestral, and then with alpha, then even with delta, then with vaccines, then it made it much easier to contain COVID. And we saw many countries bring their cases way, way down. But other countries couldn't because they didn't have the vaccines. And we saw, for instance, the huge surge in India and with delta. Now, if we had had much more vaccine equity in autumn 2020, we could have maybe stopped that surge in India, because they would have been able to make Pfizer as well as AstraZeneca if we'd done more technology transfer in the early stages. So AstraZeneca, they prepared for the technology transfer before the vaccine was approved. If Pfizer had done that, then by late spring 2021, that would be enough time probably for India to be making Pfizer. But sadly they didn't. And so that was how the World Health Organization they said, they kept saying, we can if. And they said, if we can not live with the virus but keep transmission down low, we can slow down the arrival of new variants. And they'd been saying that for months. In 2021, they started that they started saying that spring, and suddenly they were saying that a lot in summer 2021. If we can keep transmission down, we can slow down variants. If the world had listened to that, then Omicron might not have arisen until maybe second quarter of 2022. And if we do that now, if we all work together to slow down transmission, then the next variant may not come along, we might delay it for months. So it depends on us. So up to now, the World Health Organization have been saying very much it depends on us, but now they're being, Dr Maria van Kerkhove said she's incredibly optimistic that we can end the virus in 2022, that we can end this acute phase of so that's first of all is to get everyone vaccinated worldwide, reach 70% of the adult population and the most vulnerable by summer 2022. And there's no reason why, and that's not the end. We could go well beyond that. We could vaccinate all the kids in the world as well, and all the adults that want to be. And then with better and better vaccines. But we can end the acute phase with a strong vaccine rollout in 2022, so we no longer have severe disease. And then we can end, then with new vaccines, with mucosal immunity and better antibody immunity and so on, then we can stop transmission as well. And even with Omicron, if we can get to a 95% effective at stopping transmission, then we could stop it with transmission alone. Now, China would not need a 95% effective vaccine, even against Omicron. They could relax a lot with, say, a 70% effective vaccine at stopping transmission. Because it's like the Swiss cheese diagram, where if you have these extra holes, and if you have your vaccine still has lots of holes in it, but if you still have good contact tracing and good isolation and quarantine, you don't need your 95% effective vaccine. If you can do very rapid surge testing, then you can stop outbreaks very fast. So we don't need to go all the way to, we can already eliminate, like I said, this imagined other world where we use very rigorous contact tracing. If we had only the countries that did that, then we could stop it without a vaccine at all. And if we have if now, even with Omicron, those countries can still stop it. They're keeping it out. And it's not jumping from animals either. So even though it's in animals, they can eliminate it. So it counts as an eliminable disease still, so long as you're allowed to include public health measures instead of just using the vaccine. Now, if you're only permitted to use the vaccine alone in your definition of an eliminable disease, then it's not eliminable. Our vaccines are nowhere near good enough to eliminate it if you continue doing everything else as usual. But the second and third generation vaccines may well make it eliminable using a vaccine alone, and before we get there, better vaccines will make it more easy to eliminate. So instead of just China and Thailand can't eliminate it anymore because it got, but maybe Thailand will be able to get back to it, for instance. So China and Taiwan keeping it out. Maybe Thailand will be able to eliminate it again because it managed to keep it out for a very long time. Maybe New Zealand can. So maybe we get a vaccine that is good enough for New Zealand to keep it out, but not yet good enough for the United Kingdom to reduce it to 0. And then maybe later on we get a vaccine that is 95% effective, even on its own. Then we'd be able to do it even without any contact tracing, and much faster with contact tracing. So that is where we're headed next year, this year now, 2022. So the situation looks very positive for 2022. We have a rough few weeks in 2020, in the spring, in January 20. By the end of January, then that'll be the end of the Omicron spike, and then we may get other spikes, but hopefully, so we suspect that the future spikes will have pretty broad immunity, and that they will continue to be make new variants less and less dangerous with each spike. But we can't know that for a certainty, but it's quite a reasonable possibility. And then finally, by the end of 2022, with the amazing new vaccines, and as long as we stick out and go on and continue with the vaccination, we can reduce it much more. There's no reason for COVID to be as bad as the flu. And indeed, we could go further. We've got such huge developments in vaccines as a result of all the research for COVID. And for instance, as a byproduct of the US Navy new vaccine, then they found not their vaccine, but previous ones that they're building on, one of them was able to eliminate one of the common colds. Was able to not eliminate it, was able to stop the symptoms of it. And so we may well find that by vaccinating with a broad enough spectrum vaccine, if we use one as broad spectrum as the US Navy one, US Army one, then we may also find that our vaccines are eliminating some of the common colds, reducing the common colds. Only a quarter of them are coronaviruses, and we might eliminate one of those 4, so 1 in 16 of common colds, but that would be a start. And we might then go on to develop vaccines specific to common colds. And there's also possibility of progress in making a better flu vaccine. So we've never had, so flu is much less transmissible even than ancestral COVID. Flu is just 1 point something, it's R0, even without doing anything. Now, the problem with flu is that the flu vaccines don't do much to stop transmission. The flu vaccines mainly act by reducing the severity. So it's, but maybe we could get a vaccine that reduces the transmission of flu. And it wouldn't need to reduce it very much. It wouldn't even a not very effective vaccine. I can't remember the R for flu, but I mean, if the R was 2 and it's less than 2, then a 50% effective vaccine would do. It was 50% effective at stopping transmission. So a vaccine that's less than 50% effective at stopping transmission, if enough people got it, would be able to stop flu. So the vaccines for flu have never got anywhere near the capabilities of the COVID vaccine. That was a wonderful surprise when the first vaccines for COVID, when they got efficacy results. Never expected Pfizer to reach 95% of effective at stopping symptomatic disease. So it's not the same as flu. And that's why it is possible for the COVID vaccines to eliminate COVID potentially. It could become an eliminable disease, like measles is an eliminable disease. It's not eliminated, it's endemic in several countries still, including the United Kingdom. But if you vaccinate enough people, you can eliminate it. It is possible with a good enough vaccine that COVID becomes an eliminable disease by the end of 2022. And it's not impossible that some of our colds, the coronavirus colds, a quarter of them also become eliminable. They certainly would be in theory if we would know how to develop a vaccine to eliminate them. Or we'd have a good idea. Do something like codogenics and adapt it to a common cold instead of COVID. And it's probably quite an easy adaptation to do the codogenics mucosal immunity, but use it for a cold and do it for common colds. Then we could probably eliminate the colds too, a quarter of the colds. And then other developments, there's always the ideas of a universal flu vaccine, and there's ideas of trying to stop transmission with flu. So if we could do that, then we could eliminate flu maybe. So if you go back to 1900, then many people were dying of smallpox and of polio and of HIV and of tuberculosis, which we can easily stop now. And the deaths for the entire outbreak for COVID in the United States equivalent to a bit over 100 days of deaths from all causes in a non-pandemic year in 1900. So that's how far our medicine has moved forward. If you could go in a time machine from 1900 to 2021, they wouldn't say, they wouldn't be all scared by COVID. The 1900 people would say, what have you done to all the infectious diseases? Nobody's dying of infectious diseases, just this disease called COVID, and even that one, it's not nearly as serious as smallpox was when in our time, even on a non-pandemic year. So the reason COVID is so serious for us is because our medicines move forward so much, that we live so much longer, we have so many more elderly people, we are so much better at stopping infectious disease. Children don't die of infectious disease like they used to in large numbers. And for us it's very serious. But for someone from 1900, it would seem miraculous already. Well, look at that progression. Now progress it forward another decade to 2030. And look how fast our science is moving. And by 2030, we probably have got rid of flu. And we may no longer be getting any deaths from infectious diseases. We've probably eliminated measles, malaria, polio, of course. That's nearly eliminated already. So it's like a Star Trek future. Nobody dies in Star Trek of flu. So we can get that point by 2030. We could get that point, well, whether we can get that in flu, that's assuming the developments work in the flu case. We can certainly get that. There are many diseases that are already eliminable. They're counter-eliminable, like measles, for example. And many countries just haven't been able to get enough vaccine. Polio, we're likely to eliminate polio in the next few years. We've got a new vaccine, an inactivated polio vaccine, which stops transmission. It works like Sabin's vaccine, but without the drawback of mutating to make a severe disease again. And so and that one was developed with and it's now got emergency use authorization by the World Health Organization, I think, and that was funded by the Gates Foundation amongst others, and that's already being used to stop polio. And we have many other diseases that are classified as eliminable already. And with the huge expanding vaccine capacity we have in the world for COVID, then we have the possibility of not just eliminating COVID, but also eliminating many other diseases as well. And we are likely to see that as the 2020s continue. We like to see, first of all, if we get to a 95%, it's not a certainty, but I think it's a pretty strong bet that by 2022 or 2023 we have a 95% effective vaccine at stopping transmission for COVID. If we do that, then it becomes eliminable even without public health measures. And then the many other vaccine diseases that are eliminable, and we also have a completely new thing. We have the weaker economies, including Africa, have the ability to make new vaccines, invent their own new vaccines, and develop them all the way to completion using new technology, such as subunit proteins, with the vector virus vaccines like AstraZeneca, subunit proteins like Novavax, and they're making their own mRNA vaccines like Pfizer. And so they're developing their own new vaccines. So things look incredibly positive for 2022 onwards. And I don't think we even can go back to the inequity of 2019, which we took so much for granted back then. We can't uninvent the wheel. So things look very positive for the long term, and with the Omicron, the big question is what happens in this next surge, and the big question really is, especially for vaccinated countries or countries that have managed to keep out Omicron, keep out Delta quite a lot, and have lots of unvaccinated, uninfected people, then those are the countries that we know least about as to what the effect of the Omicron surge will be. And we will discover very quickly in the next 2 weeks, and then it'll be over. It'll be over, the worst will be over, different starts in different times in different countries. When you see the very high speaking cases in your country, then it's just a few weeks from there to the peak, and then another couple of weeks or so, and then it's over. So that's what you all have to expect. Okay, I'll stop this recording, and hopefully this helps.